Okay, I just wanted to talk through my work here on this example just because I want to make sure everything's clear. So the example is use a left-hand sum with 3 intervals. So from the videos, that would another way to think of intervals would be the rectangles. How many rectangles are we going to use? So we're going to use 3, and we're approximating the area under f of x equals sine x between the interval x equals 0 and x equals pi. So our interval is between 0 and pi, and we're going to use 3 rectangles. 3 rectangles. And round to the nearest hundredth. So our answer is rounded to the nearest hundredth. Okay, so here right away is my favorite graphing calculator app of all time, Desmos. Desmos can handle just about any type of equation we throw at it. So here we go. I've graphed the sine of x, and that's just following right here. And then I gave it its interval between 0 and pi. So here's 0, here's pi. And then I marked out in green here, I marked out the intervals that we're splitting it into. So we're splitting it into 3 intervals. So if I divide pi by 3, my first interval is going to be between 0 and pi over 3. Then my second interval is between pi over 3 and 2 pi over 3. And then the third interval, the third rectangle, is between 2 pi over 3 and pi. Or 2 pi over 3 and 3 pi over 3, but 3 pi over 3 just will reduce to pi. All right, so there's my nice visual. And then from the example, it said left-hand sum. We're going to use a left-hand sum. So that just means if I start my first interval between 0 and pi over 3, well, this one has no height. This rectangle right here has a height of 0. So we know that that one doesn't even form a rectangle, or it forms a rectangle with a height of 0. But then my left-hand sum between pi over 3 and 2 pi over 3, so my height goes up to here, and then it's x, its width, its x distance, its horizontal distance goes over to 2 pi over 3. And then for the final rectangle, my height is right here, and then it finishes off. Okay, so we've got an approximation of, we're kind of under the curve here, but we're not even approximating because this height, this little rectangle here, is going to be nothing. And then we've got this rectangle here, but notice how it's leaving out this space here, so we're still underestimating. And then we're catching this part here and this part here, which is an overestimate. So I've got 2 of my rectangles are underestimating the area, and my last rectangle is overestimating the area. So just keeping that in mind that our answer is not going to be perfect. All right, and then here are my notes for all this, and I just tried to copy it exactly the way that Professor Mara likes to do it. F of x equals sine x. He uses a as your left bound and b as your right bound. So a, the left bound, would be 0, and then b, my right bound, would be pi. N for the number of intervals, that's 3. LHS is left-hand sum here. And then I'm just writing a simple formula. We're trying to find the area here. So the area would be length times the width plus the length times the width plus the length times the width. Remember, these were just rectangles. Okay, now in the second step here, notice I've got pi over 3 times, pi over 3 times, pi over 3 times. So I'm just going to factor out. I'm going to factor out that pi over 3 to make the math a little simpler. So it leaves me with my width, width, width here. And then I'm remembering what is my function here. It says f of 0, f of pi over 3, f of 2 pi over 3. Well, my function is actually the sine function right here. So it would actually be the width of my first rectangle would be sine of 0 plus the width of my next rectangle, which is sine of pi over 3, and so on. Going back to Desmos, I plug all that in, make sure I use good parentheses, make sure I'm in radians mode, and round to the nearest hundredth. So we've got an answer of approximately an area of 1.81 units. All right, hope that helps.